Hello everyone, welcome to Electron Tech channel. We are going to see a problem in FIR filter design using frequency sampling technique. Problem is, here a linear phase low pass FIR filter is given. Its cutoff frequency is pi by 2 radian per second and the technique we have to use is frequency sampling technique and the order of the filter capital N is equal to 13 is given. We can see the given details. See the solution. Now we have to find the desired frequency response. H suffix d e power j omega. It is equal to e power minus j alpha omega for omega from 0 to pi by 2. Here that pi by 2 is cutoff frequency and it is equal to 0 otherwise. Now we have to find the phase delay or group delay alpha. The formula is capital N minus 1 by 2. Capital N is equal to order of the filter that we know, that is 13. So the group delay is 6. Delay we have to substitute in desired frequency response. In the place of alpha, we have to substitute 6. Next step is we have to find omega suffix k. We are taking type 1 design. Omega is 2 pi k by capital N. Here k value is given as 0, 1, 2, etc. up to n minus 1. Now we are substituting the value of capital N, that is 13. Now the next step is we have to find the sampling of desired frequency response. Formula is given. We have to find omega k for k value from 0 to 12. First let us take the formula omega k. In that formula, to get omega naught, that is k is equal to 0 condition. Omega naught, we have to substitute k is equal to 0 so that we can get omega naught. Similarly, we have to find omega k up to k is equal to 12. So here omega 12 is equal to 24 pi by 3. Omega k value, we will have some observation, that is, if k value is from 0 to 3, the samples lie in the range omega from 0 to pi by 2. Similarly, for k value for 4 to 9, the samples lie in the range omega from pi by 2 to 3 pi by 2. Similarly, for k is equal to 10 to 12 also. This observation we have to make. We are going to plot HD of omega. So next step, we have to find the magnitude spectrum of sequence H of k. Here we can find the samples. Next, the same H of k we have to represent as in functional representation. We have to find the impulse response function. Impulse response is small h of n, that we know. We have to write the formula first. After that, we have to substitute capital N value, that is 13, we have to substitute. Then we have to simplify this. Then we know the value of h of 0 and for the remaining values of h of k, that we have to write. values we have to substitute in the h of n equation. Then we have to simplify this. There are two exponentials in h of n that we can combine. Then after that, here real of exponential is given, that we can change it into cos. Then in the summation, lower limit is k is equal to 1. In order to substitute the formula, if we change this k is equal to 1 to 0, it will be better. So that additionally we are adding minus 1. Because to include k is equal to 0, cos 0 is plus 1. So to change k is equal to 0, we are adding minus 1 with that summation term. Then we are simplifying this. Finally, we are getting this equation. Then the obtained equation is in the form of cos k theta. We are using the cos k theta formula. Then first equation and second equation, and we can get what is capital M. Capital M is the upper limit of summation. M minus 1 is equal to 4, so M is equal to 3. Similarly, we can find what is theta. We got h of n. We have to simplify this. This is the final equation of h of n. Then we have to calculate the values, impulse response values. Previously, we have calculated the function. To calculate the values, first we are substituting n is equal to 0. Similarly, we can substitute up to 6. N is equal to 6 and we are getting the values. Then, since it is a linear phase FIR filter, h of n minus 1 minus small n is equal to h of small n. So we are using that formula and we are finding the remaining impulse response values. We have to find the transfer function. This is the formula for transfer function. Here we have to substitute the individual coefficient values. So we can get the transfer function. Thank you for watching this video. If you like this video, click like button and kindly subscribe this channel.